reminder, if once again, if you don't want to be recorded in our session, just like turn off your camera. And yeah, so before we start, like I'm sure you've had a look at who you've had in your team. If there's any questions with that, just like leave us a message in the Slack channel and we'll go about it. So we are doing session 2 today, the physical design and manufacture of robot. And before we get started, we would like to have the icebreaker session that we mentioned last time. So Jay will put us into separate breakout rooms.
All right.
Right. So we probably need to wait a bit for the other rooms. Right. Kai, do you want to share your screen?
All right. Let me give you a minute. Let's do the presentation. Okay. Can you see my screen / my cursor? So I'll be pointing with this. Yeah. Is my cursor visible, Jerry?
Yeah.
Okay. Cool. All right. So I'm just going to go over what's included in the kit that everyone's going to receive. By the way, we're still working on getting the kit ready. So doing the 3D printing and kind of getting all the components that we purchased / are currently being delivered into boxes to be delivered to you guys. But hopefully we'll get them out this weekend. So if you have any questions on the way, just put it in the chat or raise your hand or speak up. It doesn't matter. There's not a lot of people in this group right now. So I'll get on with it. So you saw from like the intro talk or the first presentation that this is the robot. I'll kind of first go over what's included in the robot and then go through like a step-by-step instruction of how the robot could be assembled. So this is the front of the robot. You can see over here, and over here, 3 ultrasonic sensors. So these basically measure distance between walls using sound waves. You have a gripper, you can see here. Also here, there's 2 servo motors. So these allow for the gripping movement as well as the wrist movement to pick up the ping pong balls. You have this breadboard here. This is, if you haven't done electronics design, this is kind of like the prototyping board for mounting electronics and seeing how they work. And in this competition, we'll be using this. You have a motor controller here. So this is used for controlling the DC motors. More on that in the next session. You have a IMU, which is inertial measurement unit. And an IMU is used for measuring the angular velocity of the robots in all 3 directions. And you can use this to accurately turn 90 degrees. From above, you can see the Arduino. This is like the microcontroller and used as a main processor for the robot. And finally, you can see some 9-volt batteries for the Arduino. On the back side, on the bottom, you have these 2 sensors here. These are light sensors and essentially used for detecting the white and the black on the ground, if you want to use that line. On the left-hand side, you see just a close-up of the breadboard. It's a bit messy because everything is done by jumper wires, but we thought this is the most accessible and easy way to do. All right, so just going over the components. We have light sensors, electronic sensors, IMU, some servo motors, 2 geared motors for the wheels. We got wheel, a lot of jumper wires, some laser cut plates, and 3D printed parts. Because I don't think everyone has access to the license center, we're kind of assuming that there isn't any particular hardware changes that is necessary for the robot. But if you want to make something, if you want to change something or add something, then go ahead. It's up to you. If you want to buy more components, then there's nothing stopping you from doing that. All right. So let's start from the very beginning of the robot. So this is the first floor, or kind of like the main base of the robot. And just going back, you can see that there's 3 of these wooden plates, and it's made in such a way that these plates hold these components, and you stack these plates in such a way that you can allow more components to be mounted on the robot. All right. One thing is to be careful of the direction of the plate, because they're so the position of these holes are different on, well, it's different if you place them like the correct way or the other way around. So be careful of that. Next step, you add these components you can see here. So this is actually the back side. This is the top. This is from the bottom. These effectively are like casters because there was on 2 wheels. You want to have a third point to support the robot. On this example, I literally put some tissue paper and some tape. That's fine. If you want to make something different, that's okay. But the point is just to support the robot. So whatever is fine. And another point is that these pillars here, you use nuts and bolts, whereas these things you actually screw into the 3D print. Next, we're going to mount the components. So 3 components. We got the Arduino, we got the 9-volt battery holder, and we have this plate which basically acts as a thing you push the AA batteries for the motors. You'll see this in the end. And placing it is quite simple. You literally just put them on and screw it. And you can see the red marks for the Arduino and the blues for the 9-volt battery case, and then the green is for the AA holder. Another point to be careful about is although the Arduino and the 9-volt battery holder, you kind of use nuts and bolts. This again, you screw into a 3D print. There isn't a particular reason for this. It's just that's the way it was designed. The next step, you go to the motors. So you get the DC motors in this kind of state where they're already connected to the 3D prints. They're all going to have threaded inserts, which are these gold components. And they're basically nuts that are embedded into the 3D print. So you can just screw into it and it'll be completely fine. Some of the teams might get the motors, which are slightly different in shape, but the functionality is the same. Then you add the wheels. Adding the wheels is easy. It's literally just like you put it on. It's a press fit. The next step is adding the light sensors. The key point here is to put the jumper wires before you actually mount them on, and that way it just makes life a bit easier. Also, be careful of where you place these screws. So there's 2 screw holes in the light sensor, but if you use both of them, they're gonna kind of interfere with the USB and the power jack here. So do be aware of that. So that was the end of the kind of first floor of the robot. And now we're going to move on to the second floor of the robot. So the second floor of the robot, you're going to have to glue this breadboard on the base. The breadboard all comes with like tape on the bottom, so it should be fine. The next step, you add these 4 pillars. So these 4 pillars are going to be used in the end to place the gripper onto the robot. These 4 pillars, you can just literally screw the bolt into the 3D print directly. The next step is adding the ultrasonic sensors. Once again, putting the cables in the sensors before mounting it makes life much easier. Another tip is that you can see there are 4 cables coming out of this. We'll explain to you what these 4 cables actually mean in the next lecture. But 2 of them are like power. They're 5 volts and ground, and the other 2 are for communication. And it's good to kind of have the communication over here and the power coming from the ground, just purely for like cable management and cleanliness. But that's up to you. When you put them together, this is what it looks like. You can kind of refer back to these slides when you're actually making them. Finally, once you added these 3 ultrasonic sensors, you can mount the second floor onto the first floor by using nuts and bolts on these pillars that you attached on the first floor, if you remember. There's a lot of cables coming out. So, and there's actually more cables that will be mounted. So cable management is quite important. And it's very easy to overlook this problem. But the cleaner you do it, the easier it is to debug. So do think about that when you're making it. The next step is to add components. So you can see the motor controller and the IMU and some resistors for pull-ups. you can put the cables all together into the Arduino like this. The next few slides are going to be about cable management. So I'll briefly explain them, but maybe this is something for you to come back after the next session. So yeah, more cables. You can see the difference between this one and the previous one. So here you had nothing and only the motor controllers. The motor controller wiring is quite nice because they all you can have all of these jumper wires stuck to each other and it doesn't kind of untangle. But all the other components are in different areas of the robot, so unfortunately they're all going to be kind of spread out. Once again, we'll provide with the electronics diagram and the schematic of everything once in the next session. But if you want to go ahead, then please ask in the Slack group and we can probably answer your questions. So this is just going from here to here, adding some more cables for reference. Finally, you put everything in the correct pins. So at this point, a lot of cables are just dangling around. For example, this motor cable is not connected to the motors. And then here, this is what it looks like after you connect everything. So that was the cables. It's probably going to look somewhat differently on yours, just because how you start doing the wiring, but this is just a reference. For the gripper, you have this. You have the servo here, and then you kind of put the screws inside here to mount it. You can put when you put the fingers on, make sure the gears are aligned so they actually kind of close together at once. This component fits on here as such to hold everything together. Finally, you can see the gripper that we just made. There's a wrist component here with this servo and the kind of holder here to keep the gripper stable. The actual last step is to put the gripper onto the final small plate and then screw the plate on top of the pillars that you put on the second floor. One thing I was forgetting was the batteries. So the AA batteries, there's 4 of them that you put on in this holder, and it just kind of slots inside here. And then you add the jumper wires into the correct locations in the breadboard. There's actually 2 batteries. One is the AA's, and one is the 9-volt battery. The AA battery is used for primarily the motor controls. So sorry, motor powers, and the 9-volt battery is used for the microcontroller. And the reason for this is it's if you do have luxury of having 2 batteries, it's good practice to separate out the motor power as well as the microcontroller power, because one requires a really steady voltage, and you don't want to have any noise in it. Whereas if you connect it to the motor, it's going to be a lot of noise from the motors and the back EMF. Yeah, so that's a very, very quick overview of how the robot is built. So you can go through the slides again to see, to check if you're doing something correctly. You can also probably even better look at the CAD model and then see how it's actually assembled, because that's a more comprehensive view of the robot. But feel free to ask questions in the Slack channel. So that was it from me. Does anyone have any questions at the moment? Doesn't look like it. Feel free to post in the chat if you want. But good question. Where will the slides be uploaded? I'm guessing wiki, but I'm guessing on the wiki. But Jerry, oh, there you go. Yeah, it's on the wiki.
Yeah, there are all the information should be on the wiki, and if not, you can ask us in the Slack channel, So yeah, the CAD and the slides are on the wiki.
Oh, actually, I can't find it in the old place, like for the slides. It's supposed to be next to the Minibot cat, but I'm not seeing it now.
Yeah, I've rearranged it slightly, but it's in session
Yeah.
2. There's a question about how we're going to get the kits, Kai.
It's gonna have to be an individual basis. There's no like one system to get to you guys, and it depends on how colleges are allowing people to do stuff, basically. So on the chat, I think on the Slack channel, I think we'll query team leaders or every team basically saying, you know, would it be nice if we went to a particular place, if we gave it to the porters, or however it's going to work. It's going to have to be depending on the team. But the idea is that everything, all the components are going to be in one box, and you get it and you can use it.
Should we move on?
Yeah, let's move on. And then in the meanwhile, if there's anything we can, some of us can answer. Cool.
Right. So can you see my screen? Yeah, just okay.
Yeah.
So here we got the slides for the presentation, and here you got the CAD. And now I'm just gonna demonstrate quickly how you are gonna use this. So it's a step file. It's a link to a step file, and I think for the freshers, you are using SolidWorks this year as well. If I'm not incorrect. So this is what it looks like when you open it. So basically, you download the file, and you open the step file with SolidWorks, and just click OK, like for any prompt. And so you can view the model of the bot here. So it's got all the components except the wires. So in case like when you are looking back at the slide and you kind of get stuck, this gives you a more overall view of the robot, and you can do stuff like hiding the components, or just viewing, like if you hide them, you can just like view how each fit with the other. And one thing, like given the fact that it doesn't have the components, the wirings within it, you really have to consider, like before sticking the flaws with each other, that have you, like whether you've gotten all the components within the flaws, and that you leave like openings, say for example, connections between the Arduino board with your computer. And also, if you want to do customization, you might want to try to design your components here first before like actually doing the 3D print or anything else. And yeah, and also a bit of idea of how we got to this design. We basically did a, if we go to the slides, it's not showing. Right. So the overview of creating a CAD assembly is we draw a sketch, like where we want to put the components. And for our case, for this robot, we did a bottom-up design. So we know what components we got. We got wheels, motors, ultrasonic sensors, and light sensors at the bottom. And we kind of just put it, like we bring all of the components here, and we feed them onto the sheets of board that we got. And in order to kind of get all these components, like obviously you don't want to design the bulk of this yourself. If you look at the sub assembly, got like I think you got like loads of the small components. So the idea is like you can get the CAD model at this grabcad.com. So just in case you want to add additional components, here's where you can get the CAD file. So let's move back to the slides. Now I want to talk a bit more about laser cutting and 3D printing, because these are two very powerful tools for doing rapid prototyping. So you can make stuffs in the order of hours or days, and it's relatively easily accessible. Like usually you can just do a 3D print with the 3D printers in the Dyson Center and the laser cut as well. And you can make like a wide range of shape. So basically you can just make anything with a 3D printer. And to give you an example, this is a rather complicated robot. This is the RB that we made for the rescue project. And you can see like the main framework of it is just made of laser cutting, and most of the components are just made with 3D printing. So really you can like do a lot with just these two powerful tools. So just to demonstrate how you get your laser cutting files, if we go back to the SolidWorks, say if you, for example, like if you can access the laser cutting sheet and say you want to redesign this, you look at this component and where is it? Why am I not able to open the file? So you can just save it as a DXF file. Let me try to find it. Wait a minute. I think I've got the wrong components here. So like for any 2D shapes, what you can do is open the, I can't find the button now for some reasons, but for 2D shape like that, you can do a laser cut. And to do it, you just open the file separately and you export it as a DXF file. And before you do the laser cutting, you'll have to do a training session in the Dyson Center. So they'll teach you how to do it anyways. And for the 3D printing, it's kind of similar. You go to a part and you generate an STL file. It's just another document format. And basically it gives you the file such that it's like described in a triangulated surface. And after that, you do a bit of process with a 3D printing software like CuR or DoraWare, and it makes it into like commands for the nozzle to move for the 3D printing, and that's the G-code file. And then you just like put the G-code file on memory stick, and you stick it to the machine and do a bit of like the heating and leveling settings, and just wait for like a few hours and you will get the part. So it's quite straightforward. And there's a menu for the 3D printing on the Dyson Center website. So those are some of the points that you would like to pay attention to when using the 3D printing. The print direction does matter. Like obviously, like no matter you put it like say this way or this way, you are likely to get the same. It's the same object, but if you do it this way, it will likely to be more prone to errors as it might come down during the print. And just all sorts of things that you don't want to happen, that will lead to a like failed print. And if you are printing a really like say a bit of the material in the air thing, you need to generate the support material to prevent like to actually make it like to make a shape like hanging in the air. And also another thing to consider is the placement of like nuts and bolts into the component that you are making. So a little bit of comparison of methods. In general, laser cutting is like fast with the like it can be done in the magnitude of minutes, and it's accurate because like it's just a few minutes and it will be done with the job. As for the 3D printer, it will be slow, like it might take hours. And that's why we haven't got all the parts for your kit done yet, because like we only got Kai's 3D printer in his room, and like it's working night and days to get it done. And also it might be prone to error, as I've said. If you're making a weird shape, it might just like come down like halfway through the print and you have to do it again. And the laser cutting, but it can only be used for planar objects, of course. So like for the chassis and for plates, and you could use a sheet metal, like, but it will be as an alternative, but it will just be like metalwork will be like slightly harder than using laser cut. And the 3D printer can cope with basically any shape that you can think of. And it can be used for loads of like useful stuff like the connectors, gears, and those are some of the alternatives that you can use: milling, lathe, and CNC. But these provide like parts with much more precision and it's not really, we don't really need that much efficiency. I mean precision for the Varsity Minibot that we are doing. And about accessibility at home, like laser cutters can't really be used at home. Like you can see it from the fact that you need a training session to do it, because it can produce poisonous gas if you use the wrong material, and there's a fire hazard with it. But for 3D printer, you can use it at home, and it's cheaper than a laser cutting machine. But the common point is that both of them are cheap, and that's why, I mean, like the materials and the time cost for them is really cheap, and that's why we use them for rapid prototyping. So one thing you might want to keep in mind is the tolerance of laser cutting and 3D printing. So if you are going to use it to like do the holes like for bot, which is what we did for Varsity Minibot as well, like we've got connections and pillars, and these are connected with bolts, nuts and bolts. And laser cutting, as the laser beam has a width, the holes it creates will be slightly larger than what you intend for it to do. And for the 3D printer, on the contrary, as it is built with like piling materials, when it goes under some like thermal deforms, it will kind of shrink the holes when the materials are trying to push into the space of the hole. So usually we need to leave like an extra 0.25 millimeters for the holes you make with 3D printed parts. And for the laser cutter, you like in the design, you make the hole slightly smaller. But this is really a case by case thing. Like it depends on the machine you're using, and it's really up to experience at the end of the day. Well, but it's something to keep in mind. And also like it can't be perfect. So often what you do is use a sanding paper at the end to like kind of like just make it the right size. So yeah, that's a brief introduction of rapid prototyping with laser cut and 3D print. So unfortunately, you might not have the chance to do it like this term, but this will kind of give you the idea of how to like make the robot like if you have got a CAD file design, how to make it from a design to the actual thing. And yeah, that's the most of that's what we want to go over today. And here are some of the action points for this session. I've seen like most of you have joined the Slack channel, but if you haven't, here's the link to it. It would be really helpful if we have some sort of way to like communicate with you like more quickly. And you want to get the SolidWorks or like any CAD software on your computer. I know like all the freshers doing engineering should have SolidWorks, but in case you don't, I think you can do it like by getting a stick from the engineering department library and get it on your computer. And the team leaders should arrange to collect your kit before next session. So it will probably be done before this weekend. And as Kai said, we'll do it like a case by case thing. So yeah, you really need to like, we'll reach out to you. And also like you might want to play with the CAD file and try to see if you can kind of like put all the components in the right place to like align the parts along with the nut and bolts holes, but you don't have to like assemble it before the next session. Yeah, so that's all. And I think Jay has a fireside chat that she wants to tell you.
Yep, that's right. So the next slide. Sorry. Can you
Sorry.
get the slides back
Okay.
up? I believe in the next slide is
it
hang
is
on.
it the right slide? Oh yeah.
Yeah. So next week we are going to have another fireside chat. If you remember, last week we had one with James Burton, and I think that went really well. So we have arranged another webinar with Rich Walker. He is the founder and CEO of the Shadow Robot company, which makes robotic hands. As you can see in the picture, he's holding one of them right now. He is a very entertaining person, and yeah, I think I really highly recommend you to come along to this session because you'll definitely learn quite a lot from this man. He is very, yeah, interesting guy. So yeah, just come along. It's going to be a very casual session, just like the last week. And yeah, you'll definitely enjoy it. So hope to see you there.
If you have any questions for this session or for the project in general, you can raise it now. We'll still stick around for a few minutes. Yeah, Kai, do you have something
Can
to
I just
say?
add one point? So another thing is for every team, I don't know if you announced already, but we're gonna try to allocate a committee member. So every team will have someone to, not just the Slack channel, but literally myself or Jerry or Kazuo or someone else from the committee to kind of talk to about technical difficulties or what to do next or some very specific help. And the point of us is to help you out with that. So you'll probably get a message soon who you'll be in charge with, and then each team can probably have like a very casual WhatsApp group or Facebook Messenger with that committee member and the team to talk about the robot and the technical development of it. But otherwise, I think that's it for this session, I think, Jerry.
Yeah.
And then we'll hang around for any questions, but otherwise, free to leave. Everything's done.
Yeah, Joe, you might have experience with using the Dyson Center at the moment. I don't know if you're...
Yeah, for at the moment, all the 3D printers are not in use, or at least I don't think they are being used right now. Because the second year IDP projects are going on, there are a set of RS printers, but those are reserved for second year engineers only. So at the moment, I don't think it's not clear whether you can use the 3D printers, but if I'm not wrong, the laser cutters can be booked by engineers, and you have to make sure you there's also a document of like page where you have to sign to say, you know, you have watched the training sessions and stuff, and you need to sign that document as well to just like a guarantee to say that you have watched the sessions and safety, you know the safety rules and all that. The details can be found on the Dyson Center website. They have only just recently created this booking system, so yeah, you can check it out.